Tonight's guest is an esteemed statistician, entrepreneur, educator, and finance specialist. Throughout the COVID-19 pandemic, he has been extensively investigating the global data on early and aggressive treatment and has chronicled it in his current 32-part series called the Chloroquine Wars. In this episode, we will start delving into some of that data. It is my honor to have as tonight's guest, Mathew Crawford. Good evening, everyone. Welcome to episode 3 of the Joe's Place podcast. This is Joe Giannotti, and I am honored to have as tonight's guest. He is the founder, CEO of Mist Academy, which is a school for gifted and talented students, which was headquartered in Birmingham, Alabama. He won numerous national championships as a student before heading to Washington University in St. Louis, where he studied mathematics and worked on human genome at the Institute for Biomedical Computing. Ladies and gentlemen, my guest tonight is Mathew Crawford. Mathew, good evening.
Hi, Joe. One quick thing. If anybody searches Mist Academy, that was a school that I ran for 6 years, but shut down a few years ago before I moved to Texas. But thank you for having me on. Thanks for the introduction. And I look forward to our topic. Yes.
Our topic this evening is going to be about statistics on early treatment medication. And we're going to discuss Simpson's paradox at some, later on in the broadcast. But first, I just want to get a basic, just a general introduction to you, Mathew. It is an honor to have been talking to you in the past couple of weeks. Reading your achievements is really, really something else. And again, I was part of Mathletes. I was part of Math Counts. I have a friend that graduated from MIT, who is certainly on the top of my group in the Math Counts and Mathletes competitions. But to score a 2-time perfect score on the HSME is really, really remarkable. And what got you into becoming such an incredible math whiz? I mean, hard work and determination is one thing. To become a very hard worker and excel, but you've taken it to the next level. You have taken it to a level that very few people go. I mean, there are professors, and then there are those who write textbooks. You have written 2 textbooks. The Introduction to Number Theory, is one of them, as well as Intermediate Algebra. Please just delve into, what made you into this incredible math whiz.
It's funny to hear things described that way. In some sense, I sort of considered math my first love, but don't really, I did not do the work to become a research mathematician. It didn't spark my interest to approach life that way. So I went another route, but I had a lot of tools that allowed me to analyze a lot of interesting problems. I think early on in life, I guess I just enjoyed working on interesting problems early. I was, just a little boy who liked to run around and play, and I did not like to sit still and listen to class, whether it was math class or anything else. But the moment there were, interesting problems, then I was gonna take that challenge. I didn't want any one of those to defeat me. I guess that's sort of the beginning of things. So long as you're pursuing what's interesting and find value in it, then it continues to build and head in a direction.
Exactly. And you've also not only mastered, the mathematical field and the data analysis field in reference to finances, but you've also mastered it in reference to the biomedical field. And, what are the similarities and differences between the two fields? Because you would think that biology and economics are two totally different fields. However, there has to be a similarity with data in those fields.
Yeah, and I'll stop short of saying anything like I've mastered biomedical field. It's one of those things where it's so broad. There's probably no one master of it. It's mathematics branches so quickly that you can only specialize to a degree. Whatever paths you follow down. I think I sort of lucked into. When I went to college, I didn't know what I was going to do for the summer before college. And there was this biology summer program sponsored by Howard Hughes Foundation, if I recall correctly. And so I went, and I was the math person amongst biology people. So they put me, and this is 1995. It's at Washington University in St. Louis. So they just mapped the human genome, and so they're like, "Hey, you want to work at the Institute for Biomedical Computing on statistics projects?" And I was like, "Sounds fun." So I went. It was a summer where I got to work on a lot of problems, fortunately, because the problem that they gave me to solve, I solved before lunch on the first day that they gave it to me. It was a 6-week summer internship. So they wound up saying, okay, go talk to this professor about this problem, this researcher about this problem. So I wound up getting a very quick education. And when I wasn't doing anything else, I would just go to the library and, pull books off the shelf and read, if there wasn't, a cute girl to chase at the time. Just life.
Which brings me to the next part, which is the art of problem solving. And, delve into that, because you, in 2003, became the first employee of the art of problem solving.
Yeah, I'd actually thought since middle school that I was going to build a textbook company, because I looked at the books and I was like, God, these are just so bad. Why would anybody, want to learn from this? I would wind up teaching the other kids in class all the time. So I grew up thinking that's what I would do. And then when I was on Wall Street, at the first hedge fund that I worked for, D.E. Shaw, I worked there with the guy who's the current CEO at Art of Problem Solving. And I had just started another education company. And I talked to him about that company. And, it was one of those things where it was going to be very hard for one person to do it. So, a few months after we had talked, he called and said, hey, look, let's do this together. And so I dropped the company I had, I'd been thinking about and had laid a little bit of groundwork for, and went and started working with him, and we started writing classes, teaching online, and pretty quickly after that, writing a textbook line.
And it's just, as I said, just reading your bio. I mean, I said this to quite a few people in we have a Clubhouse group together, and I have told quite a few people that I compare you to the Bobby Fischer. Like, when I would consider myself, many of my family and friends have considered myself above average in reference to data analysis and statistics. But when I spoke to you and speaking to you, it is just incredible honor. I could feel the wavelengths being passed, and I am so honored just to talk to you. So let's get right into, as we go toward the COVID pandemic. Okay. You're in Texas at this point.
Yeah.
Correct.
Yes.
So was it early, middle, or later on that you were curious about the statistics, in general, revolving around every single topic that revolves around COVID?
Yeah, I have a habit of taking notes, which it's unlike what I was like when I was young. I never took a note in anything. And then there's some point in my life where it just switched on, where when topics got complex, I always wanted to reach back for things because I would make mistakes in conversation. I would be talking about something and somebody said, oh, no, that's not right. There's, this study says this, or, this article says that. And there was a point at which I realized, there's so much complexity that what I would like to do is always have everything that I've read, as a framework. So when the pandemic started, I opened a Word doc and just started taking notes. This article says this article says that. I probably had, mid-March, I probably had 5 pages of notes, not a lot, just, things that seemed interesting. And then there was the Trump hydroxychloroquine remdesivir news conference on March 19th. And I had no idea that this would be an interesting moment to watch. I sort of barely watched it, and in fact, I don't like watching much of the politics. I sort of stand back from that and only view it as, as a circus that I can pay attention to when it needs to be paid attention to. But seeing the press, like seeing numerous elements of the press within 24 hours, already know that this drug hydroxychloroquine was snake oil that the president was peddling. I'd seen so many just combat narratives around Trump, many of which struck me as just theater. And this one, it struck me as interesting. I'm like, why? Like, why would they do this with medicine in particular? Like, that's just dangerous.
Was that when you started the Chloroquine Wars?
No, not yet. That came a few months down the road. But I started talking to friends. So as somebody, I left Wall Street after trading for 5 years, and started building art of problem solving. Then and then 2 other education companies after that. And I built so many relationships with students who are now in their 20s or even early 30s. Maybe a few in their mid 30s even. So I have a number of students, maybe dozens, who are now doctors or researchers, biologists. My wife is also, she's a biology researcher. She has a PhD in biochemistry and she studies, jumping genes, epigenetics, and she has a biowarfare defense background. So, even though I hadn't really, been in that, steeped in that conversation in a while, we would have conversations. But I would talk, a number of my students reached out to me saying different things at different times. But when I started posting, on social media, once or twice, this hydroxychloroquine thing is weird. The reactions to it are weird. I had numerous students reach out to me from numerous countries even, and I started talking with them about what was going on. And I heard about it being used, and every single person I talked to said, we think this looks good. And, that includes, people at Yale Memorial Hospital in New Haven. This is like maybe late March, early April. Somebody in India, was telling me the same thing in April.
Then there was Zelenko in late March and early April.
And then Zelenko, right, exactly. And of course, along the way, I figured out who Dr. Didier Rielt was. I wasn't really aware of who he was. I should have been probably. He belongs on the Mount Rushmore of microbiology, right? But reading through who he was and why he thought this would work, I started to discover that there were numerous papers, researchers, Kayerts, Vincent, there were numerous papers highly suggestive that hydroxychloroquine might be an effective antiviral with coronaviruses in particular, and some other papers pointing to its efficacy with other viruses. So I was like, oh, okay, I see why this was the first thing to test. Right.
And let's go further. When did you at any point read about Fauci talking about chloroquine and hydroxychloroquine in reference to SARS-1?
Yeah, there was the fact that there was a paper published in the journal where he's an editor.
That's correct. And that was in 2000. I believe that was 2009, if I'm not mistaken.
Or it might have even been 2005 or 7. It might have been the Vincent paper. I can't remember which one, but yeah, I saw that. And a year ago, I probably could have told you exactly what that paper was, what it said, because every time I heard something like that, I would go and I would read the source, right? And everything interesting. And it felt like a theater, right? Where you had these 2 icons, and people were supposed to mentally associate with these icons who had these different opinions on it. It seemed very staged to me. So it made me want to read anything I heard. I read at the time. So I think in 15 months, I've probably read 2,000 papers at this point, and it's they started to get a little cluttered, and that's why I take notes.
No, it's totally understandable. And let's delve right into it. Tonight's topic is about the statistics on early treatment medication. We're now 16 months into this pandemic. Okay. And there are many peer-reviewed studies at this point about early and aggressive treatment being effective.
Yeah.
So why isn't it being used? I mean, I would love to find that out. Why is not being used? Now, with that said, and the disclaimer, of course, I have to say on all the social media platforms is that this is for educational purposes only. And please, if you are sick, if you have COVID, please go to your doctor. Go to your doctor, get professional medical advice. However, if your doctor does not prescribe you anything or tells you the infamous words of "ride it out," which is what you're hearing, which you have heard a lot of, okay, there are, in the United States at least, there are many telehealth companies such as Speak with an MD, and I'm not a paid person from Speak with an MD, but that's who I use. And you could also go on Pierre Corey's FLCCC site, where he has a number of different telehealth sites that you can go on and try to, because it seems like the goal, as we're hearing more and more cases, not just of deaths from COVID, but the morbidity. If anything, the morbidity is much worse because it's higher. And then you hear many of stories about long haulers, and I've heard enough through Dr. Ram Yogendra and Dr. Bruce Patterson about the long haulers. And it's almost like when you have COVID, it's almost like, you're racing against the clock, Matthew, on, getting the early and aggressive treatment to battle through this. So I'm going to let you take the stage now. I want you to talk about the statistics and the different biases that you have seen throughout the pandemic with early treatment medication and all the data that has been coming out, which, through Didier Raoul, through Harvey Risch, Pierre Corey. You are working with Dr. Brian Tyson, is that correct?
Yes, and I've corresponded with Dr. Risch on that project a little bit, and earlier in the pandemic also. And I'm going to be working with more doctors soon. I've been funded by the Foundation Hippocrates in Switzerland to collect early treatment data from around the world and organize it according to protocol level analysis, which is something that I recognized was an issue with all of the data coming out, and I'll talk about that. And one thing I'm going to go ahead and say up front is early treatment data does look good. There's almost no angle you can look at it from that says that that later treatment is better than early, and of course that's common sense too. But the moment we're talking about antivirals or protective shielding, having all your vitamins and minerals, all that kind of stuff. I mean, just on a basic level, it's common sense, but the data clearly bears that out. And on top of that, it looked to me like there was the forms of analysis going on were literally hiding the levels of efficacy. In other words, whatever levels of efficacy you see about early treatment medications, the true level of efficacy is almost certainly higher, and in some cases much higher. And I'm going to walk through the mathematics of why that is and how that gets disguised according to methodology. So I'm instituting what I'm calling protocol level analysis, and starting to collect that data, and several doctors have committed. I've got data from, first it was from Dr. Brian Tyson, who was working with George Fareed, and I've got through them data from a second doctor with more coming. And hopefully, as this comes in, I'll have 150,000-ish data points. That's my goal, because I know who to go to get it. And a few of the studies that have come out, I can probably just Especially now that I have, the backing of a foundation. I think that several people will hand over their early treatment data that we already know what the data looks like, but I want to make sure that everything fits the protocol level analysis, or partition out the parts that don't. So I'll talk about what that is as I go. So the first thing I'm going to do is I'm going to point out.
Before I do that,
go ahead,
I want to ask one quick question, and I think it's a very important one before we begin. What is, we're bringing up mathematics and we're bringing up data analysis. How important is data analysis in, fields like biomedical engineering, like mechanics?
Yeah,
biology and stuff like that.
It's almost a trick question, because what we're talking about is like jujitsu. You can't do what you need to do without it. At the same time, it can be done in a way that hurts more than helps. Here's my statement about statistics: is it should be approached as a creative enterprise. Right. All of mathematics always is. We don't always, necessarily recognize the playfulness and the ability to look at things from different angles and to try to get it right. If you're not just doing math, though, right? When you're a statistician, you're problem solving. You have to make sure that the way that you're looking at things fits the model of reality as best as you can, right? And so, that's what I'm doing and trying to, move people away from what I think is a bad model toward one that is it's actually easier, fortunately, but it's much more clear, and I think gets us much closer to true efficacy. And I think that if people saw all of this, they would recognize this virus is weaker than most people think. If you hit it early,
wait a minute, I want to interrupt you for a second.
Mm-hmm.
What you're saying is based on, and again, this is based on the data, okay, that you are seeing. The virus is weaker than
based on my interpretation of the data. Like I said, statistics, it's a tool for trying to figure out the right angle to come at, the right lens to look through. And I believe that I have the right lens. I've talked about it with a lot of smart people and had ideas beat on and changed my mind about this part or that. But I think the fundamental point, which is to look at what happens when you treat people early and separate that out from, all the other data where you treat people later. And then if you do that, you actually get closer to your true optimal effect size, right? And it seems like common sense too, like once you say it, but people don't know how these studies are actually performed. They don't know that a lot of early data gets mixed in with late data. And I think people are going to be surprised when I walk through this, how that affects the way that, what the data speaks to us and says, right? So there are some serious pitfalls. So
wow.
I'll try to explain those as I go. The first thing I'm going to do a quick, I'm going to take control of the screen here. I'm going to do a quick walkthrough of some of the data that's been out there for a very long time. I'm
going to add the data onto the stream right now.
Okay.
There you go. With one sec, hold on 1 second. I'm going to do something else.
Mm-hmm.
You see, of course, my branding. I am going to take that off. So now you have control.
Okay. A site that I came across, and I don't remember exactly when I found it. I don't know if it was May of last year, but somebody was posting all of the studies as they were being put up on preprint or redating as they were published. But there were
now. Are you just want to double check? It seems like you're using C19study.com. Is that correct?
That's correct.
Okay.
C19study.com. It goes to whatever individual medicine you're looking at this point. So if you want to look at ivermectin, it'll be C19 ivermectin or C19 HCQ or other things.
However, if you go up to the top of that, you could actually get them on the bar, on the top bar. So you just go to C19study.com and then you could click on the different, like for example, you get vitamin D, you can get HCQ, remdesivir, all of them that you've heard about.
Yeah, and this was such an amazing resource for me because I was having to hunt and find out, what research is out there, and it would take a lot of time. I know how to search PubMed and and archive and all that, but still you'd find I should say at this point, we collected a lot of things. I don't know. This person may have put 80% of these up, but they also have a place where you can, offer some at the bottom. And I started participating. I think I offered up about a half dozen as I found them. And some of these are historical observations too that relate. Like, for instance, quinine, how quinine was used to help treat the Spanish flu and Russian flu and things like that. So, but then the pre-evidence, the research that I talked about, Vincent Cairns, Severino, that led up to a lot of people thinking, oh, this may work for the next coronavirus, right? Like SARS or MERS. But then as the studies began to roll in early on, mostly from China, a little bit from South Korea, but, lots and lots and lots. And there's, this page probably has 300 items on it. At this point, there are, 256 different papers studying the effects of hydroxychloroquine on COVID-19, SARS-CoV-2. And, they are...
And how many of those, does that say 223 peer-reviewed?
That may be right. I know, it's
I'm just reading it right from the screen.
Okay. And
wow,
then
that's a lot.
Out of those 256, 3/4 of them are positive. There are 65 that have a negative effect size. And I'm not, for the moment, I'm going to stay away from statistical significance, but I'm actually going to walk through the math of that some in a little bit, as long as we have time. But there's 65 showing negative signals. Out of those 65, 52 are late treatment studies. Of the remaining 13, about half of those are studies specifically focused on people with autoimmune disorders, not the larger population, just the subpopulation who has something else going on that may, interact with a disease that has its own autoimmune element to it, right? So
but I want to ask you, because something you just mentioned, very interesting point you mentioned. So you mentioned that 13 of those studies involved late with people with autoimmune.
I don't know.
Why would
maybe like 6 or 7.
6 or 7? Okay.
Autoimmune disorders. After the remaining 13 were not.
Why would you bunch those? I want to make sure I have this clearly, and I'm just trying to also help for the average person that is not a math person. Why would you bunch those studies into studies involving early, where people are getting HCQ within a couple of days after either testing positive for COVID or getting COVID, and being treated before they find out they're positive?
I don't think many people are. There may be 1 or 2 people out there who have included those in their meta-analyses. But for the most part, I think, people, no matter what their opinions, have mostly excluded those.
Okay.
So far as I've seen, there may be an exception or two.
I just want to just cover all bases and all bounds, but it seems like, based on the map, and I have seen this map, that if you look at the countries, if you can go back to the map for a quick second, just as a general, I just want to have a quick comment on it.
See if I can find it. Got so many tabs up.
There you go. So if you look at the countries that are using it either prophylactically or at the very least mixed use, it's mostly in countries where they are poorer, they don't have access to vaccines, they don't have, pretty much they have limited resources. Or there are countries where they have to use hydroxychloroquine because of different, ailments such as malaria, correct?
The malaria belt countries, they had it on hand, almost automatically, hydroxychloroquine or chloroquine. But there's been more movement to hydroxychloroquine because of resistance to some strains of.
And isn't chloroquine from what I have heard, I believe chloroquine is a more dangerous form.
Very slightly, yeah. It's a little bit more toxic. It was refined 60, 70 years ago to have this hydroxyl group that makes it
much safer.
More water soluble. It's going to flush out of your system easier, so it's not going to stay and build up quite as bad. And I don't know the exact details of the pharmacokinetics. There may be some additional reasons why, but yeah, the hydroxychloroquine, there's a ratio of about 5 to 3. 5 grams of hydroxychloroquine would be about as toxic as 3 grams of chloroquine.
Gotcha. So thank you. No, it's
and serum to help.
And from what I follow the Zelenko protocol. Okay, they are not using 5 grams. They're using much smaller doses on a daily basis.
Right. This was actually so I'm going to draw sort of axes.
Go right ahead.
Of how this thing is used and talk about how it makes sense. Because I was saying statistics is an art. You're using numbers, but you want to think about reality. What are you modeling from the right perspective? And I think the way to view this is that there are 3 important axes that we should pay attention to. One of those is dose size. One of those is whether you're using it in conjunction with other treatments. And the third axis then is time. Point at which treatment takes place, right? There's kind of a Goldilocks zone for a lot of drugs, but for hydroxychloroquine, nearly every doctor in the world is using it between 1.6 grams to 4 grams. Raul gives patients as many as 6. He'll stop using it at some point. So I'm going to go ahead and draw 6 there. So yeah, there's kind of a Goldilocks zone there. The studies and doctors who seem to have the best results, highest percentage efficacy, have been using it in conjunction with a number of different things in particular. And I've got my own preliminary data where those using it with zinc, it makes a several percentage extra absolute difference in the efficacy numbers, right? But Raul started using it with azithromycin, and a lot of people do. It is known that hydroxychloroquine is a zinc ionophore, and zinc may be a lot of what's actually keeping the virus out, though hydroxychloroquine has a few properties.
Gotcha.
So numerous other things, and I was surprised. I'm working with Dr. Brian Tyson's data, and for 3,962 patients who were treated prior to progression to moderate or severe COVID.
Let me backtrack. Let me make sure I want to direct this part. So with Dr. Tyson's data, I just want to make sure I understood this correctly. Did you divide it into different groups of people? So did you divide it to say early, then moderate, and then were there actually any severe patients? More than likely, if they were severe, they were in the hospital.
So it's protocol level analysis, and I'm getting to that with this graph right here.
Okay, go right ahead.
And then there's time, and time has been, it's been very clear that as close to day 0 as you can get. Treatment looks better than if you start at day 18 or something like that. And literally there's studies where the median time since onset of symptoms is 16 days. And, here's making sense of all this, right? If you're asking how well can this drug work for you, are you looking at its bad results? It's like, looking at a basketball player, and it's like talking about Shaquille O'Neal as to how well he shoots free throws or 3-pointers, right? It doesn't make any sense. He's right. 7'2", 300 something pounds, and pushes people around in the middle of the court. That's where he's dominant. Right. So it makes sense to ask, where is optimal efficacy happening? And it's very clear from all the data that optimal efficacy is happening, day 0, Goldilocks zone range, and then in conjunction with potentially many other things. at least at least a couple of other, whether it's azithromycin or another macrolide, zinc. Some of the Tyson and Fareed use aspirin with some patients. If they progress, maybe they have corticosteroids there at the hospital. I don't know. Albuterol, budesonide. A handful of their patients, a fraction of 1% got Regeneron therapy, but they just approached it as, what does each person seem to need according to the symptoms that they have? And there may be reason to believe that, the spike protein, just like Robert Malone said yesterday, that may be opening up the blood-brain barrier. It may be that there are so many different forms of symptomatic COVID and people's different body chemistries that you may need to approach things in a different way. And I think that's why, what's the right term? Empiric medicine, as Peter McCullough puts it, is absolutely the right way to go. And the evidence, as we look at it today, is going to point directly toward that. And I'm going to, point this out. I have no intention to be a partisan talking about hydroxychloroquine, even though there's a very particular story there. For early treatment medicine, there are a lot of things that have shown efficacy. And this is not even the full list by any means. But, more recently we have...
Matthew, can you please blow that up a little bit more?
Let me see. Yeah.
That's better.
Okay. And you can see the effect sizes. If we go with all studies combined, the effect sizes of these range from 21 to 91%. Well, that's pretty good. Okay. Well, what about early treatment studies? Oh, look, a lot of these have much higher effect sizes with early treatment and mortality results. Oh, look, what looked like, if you just jammed all the studies together for hydroxychloroquine, what looked like a 27% effect size suddenly has, for early treatment, at least 66. But I'm gonna show an argument why that's going to be better later. So, just on a logic. So it's wrong to do statistics without first establishing the logic. So here's the logic. There's nothing that seems to contradict this at all, that we should be looking at this place, this three-dimensional, set of...
I want to ask you about the conjunction for a quick second.
Yeah.
So the conjunction. So, and the page that you just showed. So if you're using a different, because it seems like Tyson and Fareed, McCullough, and Corey use different protocols, okay, for, in different cocktails. How does that work with the conjunction? And does that count as, on the data analysis? If you're taking, say, hydroxychloroquine and ivermectin together, mm-hmm. how does that work? I mean, do they both count toward being successful or failing, or does that, I don't understand in reference to the conjunction part of it. Yeah. You're using a different cocktail, or is there a way to determine between just hydroxychloroquine and then hydroxychloroquine, Z-Pak, zinc, and other things, if you know what I mean?
So this pandemic is so different than most because COVID has such a spread of symptoms in the way that it affects different people, that ordinarily you might want to isolate the effect of each drug. And to a degree, we can. We have a lot of data to do that with. Patients that I've looked at their data for so far, raw data on patients receiving both hydroxychloroquine and ivermectin, there seems to be no general, contraindication, and I've seen 0 deaths among those patients. It's not a huge pool yet that I've seen. It's a few hundred. What I'm going to do is introduce a protocol level analysis. There's a certain point at which I think that you just have to say, look, so long as the tools are there,
okay.
We're looking at conjunction therapy, but in particular, I point to hydroxychloroquine and ivermectin in the data that I've looked at so far as being the two that seem likely to have antiviral effects on their own that are strongest and clearest to see. And we've seen time curves that indicate that in some of the studies. So I'm going to point something out now. So here's my opinion. We shouldn't be paying that much attention to the late treatment studies, much more to the early treatment. This is where you get your optimal effect size, and optimal is the question that we're trying to answer. Once you have optimal, you can throw away the rest of the data and get your effect size from optimal, right? Aside from that, though, I said that I thought the effect sizes were being obscured. And I'm going to walk through the reason now, the statistics as to why that's true.
Okay.
So here's a spreadsheet that I prepared.
Just enlarge that. On the bottom right.
Oh, I see. Thanks.
You're welcome.
So
there you go.
Let's say that we've got 3 hospitals, and they're using some drug. I'm going to call it XYZ. I'm going to step away from any real medicine right now, so that we can talk about a fabricated, circumstance. We're in fantasy land right now. Three hospitals get COVID patients, and let's say that we have God knowledge of the true efficacy of drug XYZ.
Okay.
And here's what I'm going to tell you about drug XYZ is that at stage 4 of COVID, which is the point at which usually people go to the hospital, they're getting short of breath, lower oxygen, perhaps. So this is moderate COVID. 1, 2, 3 is mild COVID, and 6, 7, 8, 9 is severe COVID, and 10 is death. Let's say that here's the known, is that there is 60% efficacy in stopping mortality upon treatment at moderate stage. And I've set up the data that way. As you can see, with 1,000 patients here, 2% of them passed away, whereas with no treatment, 5% of them passed away. So you can see the 60% effect size pretty clearly, right? 60% less than 50 is 20. However, if we were to analyze this in a way where we've got 3 different hospitals and 3 different protocols, if this hospital, the first one, treats everybody the moment they walk
Matthew,
in.
I'm just going to ask slightly bigger. I want
to. This is all that fits on my screen right now. I'm not sure. You can't read this well, or
I cannot read it too well. However, you make it. You have room. You have more room. Okay, that's good. And then just that's it. That's good.
Okay.
I can read it now.
I'll move it around when I need to see the other parts. Okay.
Okay, great.
So, for the first hospital, everybody is treated the moment they walk in the door.
Gotcha.
For the second hospital, they are treated upon progression to severe COVID. And that's a policy that might be called compassionate use.
So, first hospital, I want to make sure I have this right. First hospital, they're treating right away. So, When you have moderate COVID, when you're in the 4 and 5 range, moderate COVID, treating right away. Second hospital, what they're doing is they're treating, you're already at the edge of severe COVID. You're at the beginning stages of severe COVID. That's when they're starting to treat. And third hospital is no treatment at all.
Third hospital is no treatment at all. And if we were to perform a study and just say, we're going to compare those who received COVID to those who did not.
Okay.
This is what that study might look like. If we collect all the people these 1,400 who were given given XYZ, then we have 1,400 people, of which 60 deaths occurred, which is a 4.3% case fatality rate. If we look at the 600 here, who got better before being given the drug, plus the 1,000 here who were never given any drug, then we have 1,600 people who weren't treated and only 50 deaths. So they have a 3.1% case fatality rate. So it looks like giving treatment XYZ resulted in 37% greater mortality.
Right.
And there are going to be people who say, oh, well, you can correct for this in data. The correction methods, there are all kinds of things that people do or try to do. Some of them work better than others. Some people just run this through, a correlation matrix and we did this Bayesian correction for this. And these things can be closer or farther from the actual true efficacy number. And I've seen situations where they were just very, very different at times. But we'll talk about some corrections that can be done and why those aren't good enough. So here we are, a drug that has 60% efficacy looks like it's killing 37% more people. And this is called a Simpson's paradox. And I'm gonna actually expand the definition for people who have heard that in statistics or no statistics. I'm gonna refer to this as a Simpson's effect, because it doesn't have to be true that it actually flips the trend, right? It can just dampen the trend, right? In some cases, you won't have greater mortality, but you'll have, lowered effect size. If you try to just group these two hospitals as one protocol, saying those are hospitals that treated patients with XYZ, then it fixes some of the problem, but you only get a 40% reduction in death, looking at it this way, and not the actual true 60% effect size. And I'm going to say this, of nearly every single hospital study I've seen, I am positive that the effect size is being understated because you do not have protocol level analysis. The only way to say what
essentially, and let me make sure I got that correct. Essentially, what you're saying is that you're not comparing on a level playing field.
You're not playing in a very specific way. When your protocols are different, your non-treatment group gets the 600 healthiest people from this hospital, whereas your treatment group gets the 400 least healthy people
right
in that hospital, right? And there is only one way to avoid this problem, and that is to go.
What if you just take hospital 2 out completely, and you go hospital 1 versus hospital 3?
Right, and we could do that. Let's see, did I set that up to happen here? Yeah, and then you get the true 60% reduction. The moment you take out hospital 2, that's right. But I will put that back for now.
Sure.
So, and I think that there are some of the earliest studies. There was one, the VA study, very clearly had this problem, I think. But here's the one that matters. There are several studies that made a huge, giant impact on world policy during the pandemic. The first one of these, when there was debate and question, the Surgisphere study came out.
That's the Lancet one. That's the one that had to be retracted, correct?
Yeah, and nearly anybody who's watched this believes that it was just a fake study to begin with. They had 96,000 patients at a time when there weren't even that many more patients than that, but they claimed 671 hospitals on 6 continents gave them data, which is, that sounds like such a nightmare of regulatory hurdles. And they claim that they, when asked about getting through that nightmare of regulatory hurdles, the CEO of the company said, "Oh, machine learning." And that was one of the most absurd answers I think I've ever heard to any question. But so that study came out and it was knocked down within 2 weeks and retracted. But nobody should have even believed on face that 671 hospitals, one, had that many patients, with data through sometime in April. But there were all kinds of problems with it, and I've got a couple of articles about it, but I won't go too far down, because what I really want to talk about is what happened next. So the WHO ran its own trials on hydroxychloroquine. So this is in the face of Dr. Didier Raoult in France had treated, by May, sometime in May, I think that they had treated 4,000 patients, during the first wave, very successfully with far lower, fraction, less than 1% case fatality rate, when France had hit like 30 something percent, early on. I mean, it was terrible. Right. Even later on.
Many parts of Europe were terrible. Between France, Italy, parts of Italy were hammered.
Yeah. So, Dr. Didier Raoult is doing this right here, right? So what does the WHO do? With not one but two trials, the two that people point to most, Recovery and Solidarity, they're very close to the same trial. They picked a very high dose, in the ballpark of 10 grams total,
which is of course outside of our ballpark of between 1 and 6.
Right. Then
so now that's that's I'm glad you put that in red, because that would be the danger zone.
Yeah,
those are lethal doses. I mean, as Zelenko said the other day to Dr. Drew, I mean, you can kill an elephant with doses like that.
No, it's not that bad. I'll talk about that a little bit in a moment. I think that because of the loading dose, there might be a small number of people that had a toxic effect.
Okay.
10 grams is lots of people actually take I think what would amount to be 8 grams in a sense of what their bloodstream gets up to for various autoimmune conditions.
But that's still very high.
Yeah, I think that the loading dose is a little high here. And I'll get to this. I don't think this is the reason. I don't think that this is the primary reason that the trials look terrible.
Okay.
But I'll get to that. I think we can separate that out a little bit.
Sure.
But it may have had a small effect. I think a small effect is likely.
Okay.
Then days. I think the median day to treatment was 9, but you had people being treated way up there too, right? And I'll come to that. I'll actually talk about the symptoms. In one of those studies, 60% of the patients were already on oxygen. In another one, 64% were already on oxygen. In one, 17% were on ventilators already. In another, 12%.
Well, that's not early.
Yeah, that's death's door, right?
Right, exactly.
And I'm going to bring up another spreadsheet that makes sense of what may have happened in the data.
Okay.
So and then in conjunction with nothing else, whereas everyone in the world who was talking about this medicine, and it was being used at this point, are in about 100 different nations, right? After India and Pakistan lifted their export bans when they were certain that they could meet their own needs and there wasn't a big panic, they exported immediately to 55 and 25 countries separately. And India wound up exporting to even more than that later on. So between just those two nations, they exported to 100 other countries, give or take. And everywhere in the world, hydroxychloroquine was usually being used in conjunction with a macrolide or some, zinc, vitamins, other things, right? Other things that might make a difference. And I don't think that for every patient it's necessary maybe to have zinc. Maybe a lot of patients have plenty of zinc, and a zinc ionophore is just going to help that zinc get into the cell, right? But it's just not the same thing. And so here's where they are. They're at the beginning of this axis right here. They're way out on this axis, and then way up here, right? Maybe not quite. Maybe I'll say there. Like if it was median 9 days, I think it was mean 10 or 11 when you get into the data. But it's pretty far away from here. It's far away on this axis. It's far away on this axis. It's far away on this axis. And this is a 3D picture, so you can't see quite how far apart these are, but you couldn't get much farther apart, really.
Right. And let me just, for the basic, the general person in the audience, essentially that's not good.
Yeah, and it's not only that it's not good, but here's the thing. If you're asking the question, how effective is this medication, you answer the question with its optimal use, right? It's nonsensical to answer the question with anything else, especially that which is very, very far away from its optimal use, right? Before you apply statistics, it must make sense with your model of the world. So,
gotcha.
That's absolutely the way we should be looking at this. So here's what I did last night. I said, okay, I'm going to go back and look at the data. I took the data from the recovery trial and read back through it again. And this is what I came up with. I was like, can I construct what this would look like? If you have 60% of your patients already on oxygen.
Just blow it up one more time.
Yeah. If you have 60% of your patients already on oxygen at the time of treatment.
Okay.
And
That's good.
Roughly half your patients are treated. There were 947 treated, of which 104 died, 906 not treated, of which 84 died. And it looks like you have an odds ratio of 1.18 that hydroxychloroquine harmed the patients, right?
Okay.
And doctors around the world were using this and not seeing this. So let's talk about this trial, right? This trial took place in 30 different nations at 405 hospitals.
Okay.
Now, when I say that grouping hospitals means muddying the protocols together in an aggregate that obscures the effect size,
right?
That's the extreme. By design, they have guaranteed that you will have Simpson effects. By design, even if I assume that there's that these and this is all control group right here. Let's imagine, and then some of these are control group before you start treating at this point, like on the other spreadsheet.
And again, you were doing the same thing. You're treating as in hospital 2, it's as they became severe. It's the same as what you showed us.
Yeah,
in the first example.
Yeah, and ignore the COVID severity scale. Let's just say that this is the earliest anybody was treated.
Right.
And these were the people who were treated only after they needed oxygen.
Okay.
And then you have people who were untreated up here, that 1252 minus 563, and then you have these 217 that were untreated. And you can look at this, and this is I put together what looks to me like a very reasonable set of curves. And I've kind of aggregated. Obviously, I can't put out 405 hospitals in a spreadsheet, and I don't know what the raw data is exactly. But this is a reasonable first order model of what it might look like, right?
Okay.
And here you have, there's their odds ratio. I've got the exact final data that they've got. But look at this. When you look at hospital 1, those who are treated early versus those who are not treated, what do you see?
A huge difference.
A dramatic effect size, right? This, and I don't know if this is what the final number would be. If we were to run this through my rubric, my protocol level analysis, I think that we're going to be way closer to 86.5% efficacy from their data than 18.4% harm.
The difference, I'm just looking at this. The difference is tremendous. If you took out hospital 2, if you took out, and I'm just looking at this, just trying to get, again, just trying to make sure for the average person to understand. If you essentially took hospital 2 out, okay, the severe, where they're starting to treat at the severe level, and you only looked at hospitals 1 and hospitals 3,
that's where
the difference that you're getting is tremendous.
Right. And they should have been performing an analysis like this. And I'll say this, in the paper, they kind of make it look like they're going to do this protocol level analysis by taking the people who are on ventilator out into a separate category, right? But you can't just do that. You have, really where you need to separate out is the people who are treated earliest. The people who were treated prior to being on oxygen.
Right.
And I do know that somebody has looked at that a little bit and found that it did look like there was, an effect curve. This is my understanding, at least. I talked to, actually, I'm not going to mention at the moment, but I am
going to ask you a question.
It may not be this dramatic. There may be several ways to lay out this data. I laid out pretty reasonable, progression curves. This one I had to kind of jam things in a little bit in order to make it happen, because I had to have these 3 numbers the same as these 3. And I'm sure I could make this number look like a number of different things, but it's not going to look like that.
But Matthew, what essentially you're just showing is how it is so vital for early treatment, because the earlier the treatment, the less that number 10, which is the death rate, is.
Well, I'm not showing the early treatment is superior here, but that's from other data, right? That's where we see early treatment superior. Okay. I think that that it will fall out if we get the raw data. I think that it will fall out that we have an early treatment curve. It's fallen out of every study where that data was available. that time to treatment, that you saw effect size, just tank pretty quickly, actually. So hydroxychloroquine should be viewed as a medicine. It may not be the best medicine to take after the first few days. A lot of people point to ivermectin, which has, hydroxychloroquine's effect curve may look something like that, and ivermectin's may look something like that.
Right, because if you look at C19 study, it shows that using it, you have to use it early. You can't using it late does not help.
I think
even though there was recent study came out showing that the effects of hydroxychloroquine and azithromycin on intubated patients showed a 200% improvement.
I've heard this. I don't like the language that's used there.
Now, with that said, what were the chances of death? You brought up a great point.
Right. I heard like 200% increased survival rate, and I was like, wait, was the survival rate like 10 and now it's 30? And maybe that's a 29% effect size. And that's very possible. I actually haven't looked at that paper yet. It's one of the handful that I haven't read through. But it wouldn't surprise me. And going back to why would, what is the justification for the WHO's trials, right? And what I'm saying is, this seems bonkers to me, right? Like, why would you do this? So they had a meeting at the WHO, the researchers who were first establishing their protocols. And in that meeting, they discussed that 4.4 grams was a quote unquote undoubtedly high dose. And then they went with 10, like 10.4, 9.6.
Wait a second. So they thought 4.4 was high, but yet their studies they're using even higher.
Right. It doesn't make sense.
That makes no sense at all.
And they took the pharmacokinetic information, which I read through those papers. And one of them, I think, said like 3.7 grams was your optimal dose. And another one, I think, said 3.6 was your optimal dose. But one of those two specifically said 8 looks too high. So,
right.
8 might be the point at which you begin to climb what's called the LD curve. And people might hear the term LD50, which is the dose at which like 50% of people would die. But there's the LD curve, and you can climb that with 1%, 2%, 3%. And you begin maybe climbing that curve around 8 grams, but it may be just small, maybe 0.2%, maybe at 10, it's 0.3, 0.5%. I don't know. But the point is that it may have had an effect on the WHO trials. And in particular, they had pretty high loading doses. And here's the thing, there's a justification that people will say, which is there have been other high dose trials. And I think that these are pretty explainable. They turned out to not be all that great, but the first one was, the researcher was Tang, and this was in China, and they used around 20 grams of hydroxychloroquine on, patients that were pretty critical, right? Like very, very severe COVID. And
they were essentially on death's door.
Yeah. And, you look at the data, and more patients died who received that big dose. But it's actually interesting because you have a bifurcation. You either have patients, more patients dying maybe because of toxic effects, but those who did not, those who were able to tolerate that level of dose got got on their feet faster. They had improved symptoms faster than the others. That part of the paper got removed between the preprint and the publication.
Wait a minute, that got removed?
Yeah, it was in the preprint. It was no longer there, and so that was.
Well, that's a mystery. That's a question that needs to be answered. Why?
It demonstrated, to me, it is at least a piece of evidence that hydroxychloroquine was working, so long as the patient wasn't so stressed that it caused the heart problems that people worry about. And for anybody,
which were the heart arrhythmias that I know Ramin Asqui talked about, the heart arrhythmias in those late, not early, late.
Yeah. So, yeah, exactly. I've seen 0 instances of torsade de pointe. I think that's how you say it, from the early treatment data, and over 100,000 patients, I think. And doctors are pretty good at doing this, right? This is their job. If they see your QT, prolongate enough, they're going to go, you know what, you're
plus
not.
How many billions and billions of times have they used this medication throughout the years?
About 100 billion. About 100 billion doses historically of hydroxychloroquine have been used.
Matthew, I mean, I think that would be a pretty good sample to see, all the different side effects and, effects of this.
It's possible that a drug has, some sort of a new interaction with a new virus, but, viruses aren't the kinds of things that you worry about, specific interactions with. You worry about more with interactions with other agents, as far as most medical studies go. And sure, you should be aware of the possibility, but, it doesn't seem like there's really anything there.
What you were starting to discuss.
I want to make a statement real quick before we go off this point or look any further.
Sure.
Given that the protocol is exactly the opposite of what you would want to test, and people were telling them that, and it seemed that they had some internal conversation about this as well. Given that, and given the fact that the way the analysis went is, I think a good statistician, and there are plenty of mediocre statisticians who just, they drive in a lane and they're not very creative, and whatever it is, if you want to call the WHO an elite organization, if you want to call Oxford an elite organization, they better have statisticians that are good enough to understand what a Simpson's paradox or effect is, and to set up protocol ahead of time in order to avoid that possibility. To me, this is not something that happens by accident. This type of design is not by accident. It is begging for a reduction in effect size or a reverse of effect size. It's begging for it. And it's a problem that's monotonic too, right? This is not a problem that could make the drug look better. There is no way to mix these protocols and make a drug look better. Every mixture makes it look anywhere from a little worse to a lot worse. It's a monotonic function. So
I want to ask you, I'll go there. Did you only notice this with hydroxychloroquine, or did you notice this across the board? Or you don't know the answer to that yet?
I don't know the answer to that. Any person only has so much time. Just to give you an idea, I bet I've read 85% of the hydroxychloroquine papers. I've probably read 20% of the ivermectin papers. I've read, maybe 20% of the vitamin D papers and vitamin C. And, I don't know. I have not seen it so severe as with the hydroxychloroquine. I have my own criticisms of lots of the research, and in general, science is a mess, right? Most papers I could walk through and go, no, you should do this way, or this is totally wrong, or maybe 70% of papers I could very easily do that with. The other 30%.
It's funny you mentioned science. Some of the most disorganized people that I know are scientists.
Yeah, science has gotten so complicated too that you can have many good actors in the field, many honest people, many people trying to do their best. They can be steered awry by a clever, sometimes people are on the borderline of that thing we might call sociopathy, and might take the money here or there, or feel threatened enough in their position, or pat it on the head enough times that it builds a narcissistic shield that they then have to protect constantly, right? There's a lot that can go on, but the more complicated science gets, I think the harder it gets to make sure that most of it's done well and done right. And the number of good statisticians, and this is a real problem too, right? If you're a good statistician, you can go work in a lot of places, whether it's Wall Street, Google, robotics. It applies to so many things that your most creative minds may not be in this field, and maybe we should very intentionally, like establish some highly paid positions where you pull some top quants out of Wall Street and pay them $1 million.
You mentioned something very interesting. Where they're not usually working is the federal government because of money, because you're not making the money.
I don't know.
I think it's a money thing. I do. In the private sector, you make a lot more money.
Yeah. So it's weird. I think it's different for each position, right?
That's true too.
It's also different according to the politics. At this point, we have so many conflicts of interest, like the fact that the NIH and CDC are holding all these patents that they hold, right? I mean, that is so much money, right? And who knows how that gets distributed? I don't, right? Let's say
let's
say $1 billion are made off of patents. How does that get distributed? Who makes that?
Government contractors is a different story, but remember, government contractors also still a private sector.
And $1 trillion can make 1 million millionaires. That's how much money that is, right? That's a lot of power levers. It's a lot of temptation. It can be, all the things that can tear, good faith organization intentions apart. That's just bad news. It's bad news, right? So, but you should. But I'll say this: over the years, I've probably written in the ballpark of 30 to 50 emails to different researchers after reading papers at different times and walked through Simpson's paradoxes with them. Right? It is the kind of thing that should be well understood. They shouldn't be sending people into these fields who don't understand it well, and I see it all the time, constantly. I grind my teeth every time I do. But
I mean, it's one thing. It's in a field that doesn't involve lives. I mean, unfortunately, what we're talking about are human lives at the end of the day.
Yeah. So I'm going to move to another topic, if that's okay.
Let's delve right into let's delve right into it, and I'm going to let you take the floor. I'll be right back. I'm going to let you delve right into it.
Okay, great. So, a lot of people have read studies, and I've seen people, debating effects of, debating interpretations of different studies at different times. One of the debates that I came across the other day, people were talking about, I don't trust studies that include 1 in their confidence interval. And this is a hard thing to talk through, but I'm going to tell a story. Let's say that you have a Wall Street firm, and you have the manager at the top. We'll call him the man, the owner of the hedge fund, and that person manages, 4 department heads, some of whom are better at the trading game than others. And one of those department heads is going to be the chief doofus of our story. This person has a bunch of employees doing things, and one, let's say the new kid on the block, young trader, but let's say, hardworking, bright character. And this young trader comes to, his boss every couple of weeks and says, so I tested this signal that I found. I'm trying to figure out whether to buy these stocks or sell these stocks. I'm testing the signal, and 8 out of 10 times I won. And I wasn't playing with real money, because I don't have my own account yet. I'm just helping out, Bob and Sarah trading their accounts. And over here, the boss says, well, 8 out of 10, that sounds good. But look, if we look at like a binomial distribution, which is basically the same thing as a normal distribution, there's a difference between discrete and continuous mathematics. But if we look at these results over here, we go, well, this is 8 and this is 2. And we think about this as like coin flips, either do better or worse. That right here and right here, 8 or higher, there are, I think, 56 ways to do that. So 100, I'm going to do that again just to make sure. Yeah, 56 ways to get 8 heads or more, 56 ways to get 2 tails or less. So there's actually 112 ways out of 1,024, which is, let's call it around 11%. Hopefully I did that right. Hopefully I didn't just embarrass myself, right? So, okay. 11%. So the boss says, not statistically significant. Go back when you come back when you have a trial that is statistically significant.
Okay.
So the kid comes back 2 weeks later and he says, "Oh, boss, I got 7 out of 10 this time. It's still winning." The boss says, "Well, you were working with different stocks. The signal may mean something different with these different stocks. It's really it's another trial, and this one's even further from statistical significance." So
okay.
He goes away, comes back 2 weeks later, and he's done the trials again. It's 8 out of 10. And the boss is still like, nope, none of these are statistically significant. I just need one good trial that's run well, and and the kid says, "Oh, you know what? Actually, my friend, I told my friend Raj about this signal, and Raj works for another firm, but he's a buddy of mine, and he went and tested, and he got 9 out of 10." And the boss says, "Well, you know what? I need this to be a well-run trial." And by the way, 9 out of 10 would be about 0.02 would be your p-value would be 2%
okay.
on the sales. So finally, after this goes on and on, 10, 12, 15 times, this is what happens. The hedge fund boss has lunch with the kid because he wants to eventually meet every one of his employees. It's only an 80-person firm. And the kid talks about his signal, and this guy up here listens, and he goes, and what he does is he fires this guy. Why? Because that's absurd.
Right.
Because it does, nobody whose job is at stake, who's trying to do the best with data, watches trials come back that are just shy of statistical significance, but good over and over and over and over again, and says, well, whatever.
Which has been happening for the last year plus.
Happening for the last year.
As a matter of fact, I mean, it seems like every day goes by, more good study, more, and it's essentially like that, that gentleman that you just fired. Mm-hmm.
Yeah, this is what Dr. Rayot calls a methodologist, which is that they don't actually understand what's going on well enough to reach outside a set of instructions that they follow.
Gotcha.
Right? And the methodologists, those who are methodologists as a religion, they're either that way because they don't understand or because they're hiding something. One of those two is nearly always the explanation, right? So
interesting.
Yeah, the methodologist might be your, I don't know, is this what Taleb calls the educated idiots or something like that? The intellectual but idiots.
Right.
So anyhow, so let's talk for a moment about how it is you achieve statistical significance in trials.
Okay.
And what is the mathematics behind this? Because this has gotten kind of controversial. Let's see what I have prepared. Okay. So first I'm going to explain what a p-value is. Do you know what a p-value is, Joe? Would you know how to describe that? Like, what would be your, put it?
I mean, it's been a long time that I've heard.
That's okay. I'm putting you on the spot, and it's okay not to have a good answer. I bet 90%.
Back in my days of calculus, seeing p-values, essentially, isn't that like a like I'm trying to think of like p to the x. I remember seeing like a p parentheses x is something like that where.
Well, I mean, we could describe it as a function, sure. So I'm gonna tell a story for just a moment. So in 19-
No, please do, because this helps not just me but also the general audience. But again, I remember it more as a function than anything else.
So there's no such thing as a real world probability, and I'm not gonna there's a subset of people who are gonna argue with me on that, but it doesn't matter what the core of the argument. I don't even care to stake that out as a as a position. Just that when we're talking about statistics, we don't talk about real world probabilities. We just talk about results, right? And so to say, these results represent a probability of something in the future becomes sort of a weird, it's almost like it's a nonsensical way to talk about results. So there was this statistician named Ronald Fisher, and in 1925, he was doing statistics, labor statistics. I think workplace harms, having people work more than 10-hour days, was that affecting, how often they were injured, things like that. And he wanted to figure out how to view his data. Like if you looked at one variable or another, how do you decide when you have enough data? How do you decide if your data is good enough? In other words, how do you decide whether the data affirms a hypothesis that you might have?
Okay.
Right? Since you can't talk about real world probabilities, you only have these results from data that's come out. Let's call it trials that have been run.
Right.
So what he said was, look, let's step away and work and model this in a pretend universe where this data, represents the results of random chance, right? And that's what I did with the coin flips, right? I took those.
That's right.
And I said, what is the probability that this result, or one even more extreme?
Matthew, your screen is not up. I don't know if you want to.
Right. I stopped sharing for a moment.
Yeah, you may want to share that one more time too.
Did that work?
But no, exactly. And now I'm just thinking about this. But yeah, real world probability is not possible.
Well,
in the real world, I mean, there are odds that could happen, but like getting struck by lightning, for example.
Yeah, getting down in the weeds, it becomes a really weird philosophical issue, and people talk about things like probability in terms of compression of information, and I'm not going to get into that. I'm just going to say we don't ordinarily look at data and talk about probability that something will happen.
Gotcha.
But what he wanted to do is have a metric, have a number that he could point to, and he came up with this notion of taking this right here, calling it a p-value.
1 second before you begin. I have to interrupt you because you are not sharing the screen, so I want you to share the screen.
So everybody can see it. I'm back up. Let me try that again.
Oh, wait a minute. You are? Give me 1 second. I have to do it on my end. Sorry. There we go.
Okay.
Go right ahead.
So he came up with this idea of calling this this 11% number a p-value,
okay,
and saying, well, is this value less than 0.05? And if it was, he said, well, that's a statistically significant result. 29 years later, he wrote a second book and said he regretted that because people were taking this and turning it into the methodologist paradigm. It was becoming a religion, as if some angel had come down from the sky and said,
gotcha.
This is the point at which you pay attention to results.
I understand.
When his real point was the economics of his own time and the impact of the study itself. Like, how important was the study itself, right? It was something that was a common sense idea for him, a good rule of thumb for him to perform his work by, and it was turned into something that was a religion. It
was totally misinterpreted.
Well, I think attempt at interpretation by people who either didn't get it or had a motivation for using it, right? One of those two things, right? And he was before the era of randomized controlled trials, right? This is 1925. Your randomized controlled trials appear in the 1940s. Maybe there was like one in the 1930s. I can't remember exactly. And then by the 50s, they're all over the place, and he's looking around going, you know what? My statistical methods aren't what they say they are, right? And he said this on multiple levels, right? That 1954 book, I can't remember the titles of his books, but it seems like he's saying these people are statistical zombies. Really, this is this. And most of your good statisticians that you talk to,
okay,
you go to a meeting at the American Statistical Association, they've written papers saying, we don't support this idea of 0.05 being this one mark that measures everything. Even aside from that, though, okay, so we can find these p-values. Some of them are cleaner than others. If you have an RCT, on average you get cleaner data, but how much does that matter historically, right? They're the people who say RCT. If it's not an RCT, it's like it doesn't exist. But here's the thing: none of Fisher's experiments were RCTs. Not one. They hadn't been invented yet, right? And so you have all this data, and in fact, the vast majority of drugs that the FDA approved, were drugs that were being used prior to the invention of the RCT. They didn't stop the show and say, well, we don't know if they work because they haven't been through an RCT yet, right? It's an absurdity, but people don't know how and why it's an absurdity. So I'm going to talk about that a little bit. I'm going to talk about what it means to power a trial, and I'm going to show some curves for a moment, and then I'm going to come back and try to give an intuitive explanation of these curves.
Sure.
This is a spreadsheet just made to generate power levels of experiments. And sorry, I didn't write chart titles, but I'll explain what these are. Okay. Let's say that you want to see what sample size, what N is going to be for some trial that's being run. You want to know, at what point am I likely to get a result that's not a false positive?
Okay.
And there's, there's beta and 1 minus beta. And this is where, I'm not usually in this field. I sometimes lose track of the jargon. So excuse me, I think I might be talking about type 2 errors. I'd have to stop and think for a moment. But anyway, the point is that you need a certain number of values to get to the point where you have a high probability of statistical significance in your result. And I'll go through in a moment math why that is. And here we have comparison of RCTs versus observational trials.
And it looks like you have 3 different. I just want to make sure. One is small effect, one is medium, and one is large. Correct?
That's right. The higher the effect size, the easier it is to measure it. Right? It's like if one basketball team is just way better than another, you don't have to play many games to realize that.
Right.
But you have to go at least 7 when you get to the best teams. Right.
Right. But when you have, I'll give a sports example. When you have 2 very similar teams, such as like the Yankees and Red Sox, then that would what would that be considered more of a small effect? I mean, how would that?
Yeah, funny. I read a paper one day where they said it would take like 255 games to actually determine, who was the best team in baseball. But so with these right here, you can see that under certain conditions, randomized control trials reach a good level of powering. Let's say, it might be 400, 500, 800, depending on what you're trying to measure, right?
Wow.
And it takes non-randomized control trials, maybe a few thousand to catch up. But once you get to a certain point, the results are pretty much
the same.
As far as like saying this is enough data to make a conclusion from, right? And this is not controversial, and every statistician,
And I want to ask a couple questions in reference to this. Mm-hmm. So, for example, if you have let's start off with Brian Tyson's data. Let's start off with 4,500 patients. Okay.
Right.
That to me is a relatively large sample size.
Yes.
So
it is.
That would be part of the large effect size meta-analysis. So you would see that it's pretty good. But how about a doctor that only has 50 patients or 100 patients? That's my first question. Right.
This is where people are going to point to those lines in a pool of data and go, well, your confidence interval still includes 1. Even though there are 256 studies out now, right? They're going to go, but this trial had 1 in its confidence interval,
Right.
So don't be an idiot. Act as if your job is on the line. Lives are on the line, right?
Yeah.
Personally, I think the WHO trials And I can't say whether that was intentional or accidental sabotage, but those trials may have killed 2 million people, give or take.
Wow.
Depends on what you believe the final effect size is. But when I look at the early treatment data, I see the multi-drug regimens with 98-ish% reduction in mortality. So anyway, back to this point right here. And there's research. There are researchers, I can't remember all their names. Concado is one, but there have been researchers who looked back and said, do observational trials give you as good confidence in an answer as randomized control trials? And it turns out that the results of the two do look almost identical after you get to these points where you would expect them to look almost identical. It happens. We know it happens. So it's actually an absurdity to, it's an absurdity, to talk about only needing RCTs, right? The guy who came up with the statistical framework for measuring these things didn't need RCTs, right?
Right.
And they're not appropriate in some situations, because if you already think that there's an effect size enough that, that you might want to test for, it's inappropriate not to be giving some people medicine.
Right.
So, there's all kinds of things that are wrong with this idea.
There are too many variables.
Yeah, and medical science used to be done just by looking at case series, protocol level analysis. And it turns out that may have been giving us better answers all along.
Wow.
And this is exactly the moment, this pandemic, where you have a disease that has so many different effects, right? That's where you're going to have the biggest problem, and you're going to have the biggest difficulty with people who think they might be able to hide because of those difficulties. So now we talked a little bit about powering levels, and I don't know how intuitive I made that, but now I want to talk about binomial distributions.
I want to ask, before you get into that.
Yeah.
I want to ask a second question. Is there a way that you can combine data to get?
Oh, I meant to talk about that. So thank you for asking that. Yeah. So here's the thing, can you just aggregate data across trials? Right. And it's a tricky question as to whether or not you would want to. Some people go, well, now you don't have like epidemiologically matching cohorts in the same way that you might have before. But you know what? You know what those 2 WHO trials did? Basically, every one of those hospitals, 405 hospitals in the recovery trial, each one of those was a mini trial.
Right.
They aggregated all those together. They could say, hey, look, it was the same treatment protocol, but do you believe that all the patients were the same between those different locations? Do you believe that the hospitals were of the same quality? Do you believe the doctors were of the same quality in 30 different countries? Right.
Well, of course they weren't.
Maybe not. Right.
I mean, maybe, but I'm saying more than likely, probably not.
That study already could be reasonably viewed as a meta-analysis and an inappropriately aggregating meta-analysis.
Gotcha.
I think that it's perfectly okay to group things together so long as you understand what you're doing and what the limitations are, right? They make no rules for exactly how dirty data is dealt with. Ultimately, what happens in these papers is people with high enough authority kind of get the wink and nod to play faster and looser with the rules and with whatever justifications they come up with. Like I said, you have to make sense first. You have to, the statistics have to fit reality. And so long as, it's a judgment call. You just need enough smart people in the room talking about it and understanding it and agreeing to it. But that's not what we have. We have a hierarchical system that is more like a church than actual science or anything that you might call, quality.
Which is very sad, which is really, really sad.
Yeah. So
here we go.
What happens, and this is part of the conversation of statistical powering of trials. Maybe I should have made these bigger. I'll see what I can do here. So this is
that's pretty good. That's pretty good.
This is a graph of results from flipping 50 coin flips, and I cut off the tails because there's almost nothing there, right? this may not look quite as ordinary as the normal distribution that you see most often, but the smooth version of this is that normal distribution. There's your bell curve.
Yeah, that's your classic bell curve.
Yeah, and there's extra lessons here. There's a lot of lessons in this curve, and so this curve shows up everywhere in the world, right? Why is that?
Yeah, why is that? By the way, college students want to know why. That is the case too.
I'm sure there are plenty of people in science who want to know why, and they may or not know the name of the central limit theorem. But okay, ultimately, this is your curve of coin flips, right? Okay. It's smoothed out. Let's say that you have a whole bunch of genes that affect your height, right? And it turns out there are thousands of them that have some correlation that can be measured, the height. So you have thousands of little coin flips, and those thousands of some of those have a bigger effects than others. It turns out that unless one of those variables is just totally dominant, you wind up with a bell curve regardless, even if the coin flips aren't weighted the same way. You basically get this curve. Might be slightly flatter, whatever, but you basically get this curve. So this happens all over biological sciences. There's a book. It's funny. Early on during the pandemic, I started to try to make the argument that you didn't need any of these early treatment medicines to work that much, because there were people going, "Oh, this worked in vitro, blah blah blah. It might not necessarily work in vivo," or coming up with like excuses for reasons to be dismissive of the idea of early treatment medication. And I was trying to come up with like a good argument as to why this was just bonkers. Like, it seemed on face bonkers. Like, why aren't you making arguments to try to do this? But I came up with this idea that I called the nudge, and then I looked it up online, and there was a book called The Nudge that was the same idea. Authors Sunstein and Thaler, and they're talking about sales, right? They're talking about
yes,
maybe you make the sale right here. But if you can take this curve and bias it, if you can make it a curve that has, instead of 50 heads and 25 heads and 25 tails, if the coin is weighted just enough that it becomes like that, then you've increased the area under the curve at the sales point, and that's a lot more cash, right?
It's interesting. I'm going to tell you a comment that came over on the stream. Very interesting. And someone wrote that they're understanding some of this, but it's becoming clear that what we're having the conversation on, that we're an hour and 40 minutes in, the WHO purposely, I wouldn't say purposely, but the WHO seemed to misrepresent the data and the average person, okay? And which is why I'm asking questions for the average person to try to understand about data, because it's not an easy topic. It is for the average person that, focused on family, focused on, meal on the table. Most people do not understand, okay, the nudge effect and bell curves.
Right.
But I'll tell you who does. The statisticians that work for the World Health Organization and all these other companies and all these health organizations that are an important part of human lives. Maybe
there are.
You might be right. Maybe not. Maybe they don't.
The fact that this book called The Nudge was only written like 7 years ago tells me that the concept is novel to more people than you might think, right? And just having the experience of being in a lot of different positions. People are good at a lot of things. People aren't good at the same thing. People aren't good at the same thing that I am. I'm not good at the same thing they are.
Right.
You do wind up with a lot of people who are very skilled, but within they may wind up in a position of authority. Call it the Peter principle in action, right? They may wind up in a position where they just don't know how to do everything, in order to create the largest scale intuitive picture. There should be more smart people invited into the room, though, right? At the very
100% correct.
You're trying to check for corruption, because if you're not inviting outside smart people into the room, if you don't have Richard Feynman at the table at the press conference with an O-ring dropping it into the glass of water, right? He wasn't from NASA. He didn't work for the government.
Right.
They put him on a panel because they wanted somebody from the outside who was a smart generalist. I mean, he was a smart specialist too, but they wanted somebody who could make that transition. They should be doing this. They should be hunting for the Richard Feynmans of the world to put in that room and have that conversation. And if you don't, you are begging for corruption. If you don't, you're begging for disaster, yes. Right? It should be part of every pandemic, every disaster, every.
You brought up an outstanding point that you should have on your panel unbiased, independent voices who I would consider in the sports realm umpires, and officials.
And the COVID-19 treatment panel, it's stacked with pharma people, right? There was not one person assigned to go out and collect the early data. So I'm doing it now.
All you got to do is Merck. Merck is your classic example of this. Merck is your classic example. Okay, here is Merck, who created, to the best of my knowledge, I want to make sure I'm right, created ivermectin. Okay.
No, ivermectin was discovered in Japan, but they had
the distributor. I'm sorry, they're a major distributor in the United States of ivermectin.
Something like that, yeah.
And they are saying something negative about their own drug.
Right, yeah.
Saying something negative about their own drug.
Yep.
Then if you thought of this drug as so negative, then why did you sell it for decades? Why did you sell the drug and make so much money through the decades when you had the patent?
Yeah. These questions are not answerable in any good way.
I'm sorry, I'm deflecting from nudge effect, and I want to get back into that. But
these questions are for everybody to be talking about right now. This is the reason why I'm presenting these statistics, is because I think that we are at the point at which those questions are critical, right? I don't know if, I think that this is more of a panic than COVID-19, right? I'm much more worried about the system's imperfections than I am whether or not COVID-19 is going to, take over the earth. It's not. But coming back to this, lots of little effects making a bell curve, making a normal distribution. It's common. It's all over biology, and it would probably make a good first-order model for what happens to an individual who gets the SARS-CoV-2 infection, or even just a load, right? To be exposed, right? And some people might be exposed and not get an infection. Maybe these people to the right get an infection. Maybe these people to the right get COVID. Maybe these people to the right get hospitalized, and maybe these people die. And you know what? This right here, for the black curve, which is the one that is ordinary health, that's your, this is your normal distribution before the nudge. That is infection fatality rate. And if the last I saw it was 0.14%. And somebody can correct me if that's wrong. I don't care exactly how wrong it is. We're in the ballpark, right? What happens when you perform a nudge? If you make people a little bit sicker, that area under the curve at that point, that might explode by like 2-3 times. If you pushed it the other way, the area in that tail, it might diminish by 90%. It doesn't take that much of a nudge. It doesn't take that much additional health impact from a medicine to move the curve such that you're saving 90-something% of the lives.
It's very small.
it's very perceivable, very believable, right? If you are helping somebody with their zinc deficiency or with their vitamin D deficiency, or helping them get vitamin C through enough of their body that it works the right places, or ivermectin, which does, I don't even know if we know the mechanism. I don't think we don't know the mechanism for most drugs or even most agents, right? We only knew the mechanism for aspirin a few years ago. But when we see these effects, when we see what needs to be done, and we have good clues, all these things only have to add up to a little bit of a nudge. Can you make somebody who is 50 percentile health into somebody that is 53rd percentile health? That's your average nudge effect.
That's right.
If you can do that, you may be collapsing most of the area under the tail. And that's what we could be thinking about this problem is, can you do something that makes a little bit of a difference? Because it may make a huge difference.
Yeah.
Aside from this point on the nudge, I have one more point I want to make, or at least one that comes to mind.
Go right ahead.
I had a lot of things on my list and didn't know how many I'd get to.
And by the way, someone asked about, someone had just asked just now about lockdowns.
Covering another time if we.
Okay, that's fine.
Yeah, I kind of want to. Oops, I'm showing everybody my notes right now.
That's okay.
One more thing that I want to say about meta-analyses, actually. The meta-analysis
Go right ahead.
Published. I've seen several published that have been somewhat negative, both on ivermectin, hydroxychloroquine, other drugs, and I want people to understand this. Whether their inclusion-exclusion criteria, and what happens prior to the point at which people decide what evidence is involved is somebody rates these on a bias scale, right? This is an opinion. Anytime you have an opinion, you have something that can be gamed, right? Read the rules for like Cochrane rapid review. Most people don't realize this. And it's even been studied. Do researchers come up with the same bias scores? And the answer is no, they don't. Not really.
Right.
And if you look through, if you're really interested in this topic, look through the actual studies that get included or thrown out of some of these trials. And in some of these cases, it's bonkers. I mean, personally, what I think about the WHO trial. I've written, there are a number of the other trials, and they lean negative overall. The ones that I've read through that I don't think are worth anything, or are at best disguise effects. Right? There are 6 different trials that don't use a real placebo. 6.
Oh wow!
I'd never seen one. I'd never seen one in the history of medical
6.
trials. There are 6, right at this point. 3 that used folate, I think, and 3 that used vitamin C. Meaning, and we don't know how reactive these are. We don't know exactly. They should be studied, more.
Wow!
But that disguises effect size potentially. And we should hope that it does in a sense, because it would mean that we have more agents that we can use. But we, whatever you see with these, meta-analyses, remember that for hydroxychloroquine, there are 29 early treatment studies, and I think 29 positive results. Not all include one in their confidence interval. Right. Don't be the idiot boss. For ivermectin, there are like 58 studies, maybe 56 are positive or something like that. Maybe 24 RCTs, 23 or 24 were positive.
I'm going to tell you, this has been an amazing topic. We are only beginning on statistics of early treatment medication. This, you can see from what we've discussed tonight, okay, that this is a tremendous topic. This, as I said, this requires many different parts. And I think when we...
Joe, if I could, you may be wrapping things up. We're at a pretty good wrapping point, but I have one more point to make about meta studies.
100%. Go ahead.
Yeah. So here's the last thing I'm going to say about.
Do you want me to share the stream again?
No. I don't need to.
Go right ahead.
So you have these meta-analyses, and let's say that they exclude some trials for risk of bias or something like that, and then they group effects and they come up with effect sizes. You know what? If you look at those effect sizes, and you look at some of these excluded trials and you go, wait, these had the same effect size as the average effect size over here. So it looks like they were trustworthy after all.
Right.
Isn't this the way ordinary people look at ordinary evidence in the world when they're trying to do their best?
Exactly.
It's like hearing a story, wondering if somebody's lying, but then you see several pieces of corresponding evidence and you go, okay, I'm not going to think of that person as a liar and exclude them from, my grapevine, right?
Right. Exactly.
So if you were to go back and include some of that evidence and bring it into the pool, it makes the evidence pool even stronger. That's not always appropriate. It depends on the reason for bias, right? It depends on the reason that you held it out. But the fact that nobody does this, and the fact that nobody even suggests doing this, but feedback loops make things better, right? This is why the best results in the world are coming from doctors like, Dr. Tyson out in California, who, he could try different things with different patients and see what was working. And he may have used a dozen different medicines. I mean, you could say during the first wave, hydroxychloroquine was the centerpiece. During the second wave, it was both hydroxychloroquine and ivermectin. But there are all these other things that he used: aspirin, budesonide. The
whole cocktail.
What you're doing is treating medicine as a constant feedback loop, and not depending on all these hurdles to cross before saying X, Y, and Z. The results are just better, right? This is what we should be doing. It makes sense. It's not true that it makes sense to stand behind the gate of all of these methodologies. You stand behind that gate and you're condemning people to death.
Matthew, we're only getting started. I mean, that's this again, figuring out the puzzle is just this. What we did tonight was just, scratching the surface of the puzzle.
Yeah. And if you want, like I told you before we started, I actually outlined 5 different lessons. If you're interested, we can continue.
I am very interested.
Yeah. Thanks for having me on. Thanks for giving me the opportunity to share, some subset of my thoughts during all this. I hope that
Matthew, I would love for you to come back on a weekly basis. Maybe every Saturday night we can do this and discuss this, because I think the data part of COVID has been, not looked at in any way, shape, or form. And the biases that you are showing, the biases that you are showing, okay, and the fact that the data that has been looked at has been so unfairly biased, has sadly led to the deaths of so many people. And
probably.
Matthew, I want to thank you for being on tonight's Joe's Place podcast. I will talk to you. I would love to do this every Saturday night and have a whole series of discussing this. Once again, thank you for coming on. Sure. And we are going to end.
One more thing. Even though I haven't typed anything in, we have the site live for the early treatment data. And by tomorrow, there will be a little bit of basic data there, but we have a URL, which is www.earlyc19treatmentdata.com. earlyc19treatmentdata.com.
One moment. I want to make sure I get this correct. Hold on, because I'm going to put it on the screen for everybody.
Okay.
It's early C19 treatment data.com.
And I'm going to lay it out like a scientific paper, but I'm going to add arguments that usually aren't in there in order to.
Matthew, please make sure if you could see the screen. Is that correct?
Yeah, that's it. Oh, yeah, that's it. That's it. earlyc19treatmentdata.com. Yeah, and as I get data in from the doctors, I'm going to clean it, sort it, put up the early treatment data, and show optimal effect size as well as I can display it. And I've been given indications of what some of the data pools say. I've read some of the papers, so I think it's going to look very, very good. But there's 150 data points out there that I'm talking with people to try to get. So it's going to unfold over the next few weeks. So,
and what we'll do is the next time you come on, we will go onto the website. We will start right off the bat, right on the website, and we'll talk about some of those data points.
Sounds good.
Mathew, thank you for coming on, and I thank everyone between YouTube, Facebook, Twitch, Periscope, Twitter, as well as Clubhouse for listening and watching tonight's Joe's Place podcast. This is Joe Giannotti saying so long, have a great night, and enjoy the rest of your weekend. Bye-bye now.
Thanks, Joe.